everyone! Today I'm doing a rapid review of spinal muscular atrophy, or SMA. It's a condition that causes a progressive loss of motor neurons, which are the nerve cells that tell our muscles to move. Now, most SMA is caused by a problem with the SMN1 gene. Think of SMN1 as the main producer of a crucial protein, the survival motor neuron protein. If a person inherits two non-working copies of SMN1, one from each parent, the motor neurons don't get enough of this protein and begin to wither away. Now, we all have a backup gene, SMN2, but it's not a very good one. It only makes a small amount of the functional protein, and it's the number of SMN2 copies that often determines the disease's severity. So let's break down the inheritance. First, let's look at the case of an unaffected individual. In an unaffected person, their genetic blueprint includes two functional copies of the SMN1 gene, and typically one or more copies of the SMN2 gene. Both of these genes work together to ensure a plentiful supply of the SMN protein. Next, let's look at the case of an unaffected carrier. An individual who is an SMA carrier has a unique genetic makeup. They carry one fully functional copy of the SMN1 gene, but also one copy that's either mutated or deleted, a non-functional copy. Alongside this, they still possess one or more copies of the SMN2 gene. Thanks to that single functional SMN1 gene, they produce enough functional SMN protein to remain completely healthy and show no symptoms of SMA themselves. However, they carry the potential to pass that non-functional SMN1 gene to their children. Now, here's a twist. Sometimes a person can carry two copies of the SMN1 gene on one chromosome and zero on the other. This makes them a silent carrier, because a regular carrier test would miss it. That's where a specific marker comes in called the C.3+80T to G SNP. This single letter change in the DNA is a valuable clue that a person might be a silent carrier, especially in certain ethnic groups like those of Ashkenazi Jewish or African descent. So the presence of this SNP can actually increase the risk of being a silent carrier, even if you test positive for two SMN1 genes. This brings us to individuals actually affected by SMA. Someone with SMA has inherited two non-functional copies of the SMN1 gene, usually one from each parent who was a carrier. They also have a varying number of SMN2 gene copies. With no working SMN1 genes, the body relies almost entirely on SMN2. The problem? SMN2 primarily produces a mostly non-functional version of the SMN protein, with only a very small fraction being functional. This severe deficiency in functional SMN protein is what leads to the progressive muscle weakness and other symptoms characteristic of SMA. However, people affected with SMA can still have a milder phenotype if they have a higher number of these backup SMN2 copies. The increased number of SMN2 genes collectively yields a larger amount of functional SMN protein compared to severe SMA. And that's your rapid review. Hit that like and subscribe button for more quick study tips. Feel free to share your tricks in the chat, and I'll see you next time.